Hello friends, welcome to the next lecture of the module number 1 in which we are going to study about the Feastel cipher. This Feastel cipher is the basic block cipher, or we can say this Feastel cipher provides the basic working functionalities for the block ciphers. In the previous lectures we have gone through the introduction of the block ciphers. We have even covered the topic of block cipher principles, where we saw that the working functionality of the block ciphers depends upon the principles of the substitution and the permutation, in which the substitution of the letters and the permutation of the letters takes place. And whenever the plain text block comes for the encryption process, that plain text block will undergo the substitution and the permutation conversions for converting the plain text into the ciphertext. So let's begin with the explanation of the Feastel cipher. Guys, Feastel cipher is not considered as a specific scheme for the block cipher, but it is considered as a design model from which many of the different block ciphers are derived. In the previous lecture, I must have told you that there are different block ciphers available which we have to study. Those are AES is there, DES is there, triple DES is there, MD5 is there, RC5 is there. So these are the different types of the block ciphers, but the basic design model for these block ciphers is the Feastel cipher. They do work upon the basic functionality, that is the Feastel cipher's functionality. So the Feastel cipher executes two or more simple ciphers in sequence in such a way that whatever the final resultant you get as the ciphertext is cryptographically very stronger than any of the component of the cipher. Whatever the process we perform for the encryption to convert the plain text into the ciphertext, whatever the number of rounds are being used in the Feastel cipher or in the other block ciphers for converting the plain text into the ciphertext, the product which you get at the end of the encryption process is cryptographically very stronger than any other component of the ciphers which we have studied till now. So Feastel ciphers are special class of the iterated block ciphers, where ciphertext is calculated from the plain text, and for converting this plain text into the ciphertext, repeated applications of the same transformations or the round functions are used. Now here it is said that repeated applications of the transfer functions or the round functions are used. That means when we say that there are n number of rounds have to be performed for the process of encryption. So in every round, the number of bits which are coming for the encryption process will be undergoing the process of substitution, will be undergoing the process of permutation. So these bits will be then changing their positions, will be then changing their structure in each and every round, and therefore it is said that the ciphertext which is calculated from the plain text, it is being calculated by the repeated applications of the same transformation in the number of rounds. So the number of rounds will be performing the same function, but the bits which are coming for the next round for the conversion of into the ciphertext will be different bits. So the Horst Feastel devised the structure of the Feastel cipher. This concept is basically dependent upon the invertible product cipher. Product cipher, product of the substitution and the permutation, or we can say product of transposition and the substitution technique. Here, whatever the plaintext block comes for the encryption process gets partitioned into two halves, left half and the right half. Every half then processes through the multiple rounds, and those multiple rounds have to perform a substitution on the left half of the portion of the partitioned plain text block, and then based on the round function, the right half and the subkey is then processed. Then the permutation takes place wherein the swapping of the halves take place, and this is nothing but the implementation of the Shannon's SP concept, that is Shannon's substitution and permutation concept. Now this is the diagrammatic representation of the encryption process, wherein you can very well see that whenever the plaintext block comes under the process of the encryption, that plaintext block can be of any size. Here we have considered, or generally it is being considered, that the block size is of the 64-bit. It is then divided into the two halves, that is left half and the right half. So every half will be having the equal number of bits. If it is a 64-bit block, then the left half will be having 32 bits and the right half will be having 32 bits. In the round number 1, the left half undergoes the XORing operation, and for this XORing operation it does require a function key, and that function key is nothing but a key which is being generated for that respected round. Here, in every block cipher encryption process, the random key generator algorithms are being used for generation of a random key, which is being then utilized by every single round. A new key will be generated for every single round of the working of the Feastel ciphers and the rest of the block ciphers. So here, the XORing takes place with the function. That function is nothing but a key function, and using the random key for that particular round. Once the XORing takes place, the XORed output is then shifted to the right hand side, and the right half of the plaintext block is then shifted to the left hand side. That means here the swapping of the bits takes place. The 32 bits which were previously the left half portion of the plaintext have now become the right half portion of the plaintext for the next round, and the 32 bits of the first plaintext blocks, which were the right half portion, have now become the left half or the left hand portion for the working functionality of the second round. So here the swapping of bits took place, and then the swapped bits, which now has become the input to the left portion, will then be undergoing the XORing operation in the next round, and the XORing operation will take place with the function key, which is being then generated for that respected round. The same process will take place, wherein the XORing operation will take place on the left portion, and then whatever the output you get after the XORing operation will then be going as the input for the right half of the next round. So this process will take place for the n number of rounds. Whatever the number of rounds are decided by that particular block cipher, those many number of n rounds will then be calculated, and the output which you get at the end of the nth round is again needs to be swapped. If that swapping won't take place, then you will not be getting the ciphertext. Similarly, if this particular swapping is required for the decryption process also. So at the end of the nth round, whatever output you will be getting, you will then be getting the ciphertext of the plaintext block which came for the encryption process. And at the end, whatever the ciphertext block you will be getting will be of the same size as that of the plaintext block. That means if your plaintext block is of 64 bits, so you will be getting the ciphertext of the 64 bits only. Now, the decryption process. The process of decryption in the Feastel cipher is almost similar but not completely similar. It is not exactly same as that of the encryption process. Instead, starting with the plaintext block, here in the process of the decryption, the ciphertext block is fed into the start of the Feastel structure, and then the process thereafter is exactly same. It is then described in the figure which is in the next slide. As I told you that the process is almost same but not exactly. In case of decryption, the only difference is that the subkeys used in the encryptions are used in the reverse order. they are not used in the same order as they were used in the process of the encryption. They will then be using its reverse order. That means in the process of decryption, we will have to find the inverse of the key. And then that inverse key will then be used for the process of decryption. And the final swapping of the left and the right portion in the last step of the Feastel cipher is essential. As I told you just now, that it is very much essential. If that swapping doesn't take place, then the resulting ciphertext couldn't be same, or the resulting ciphertext would not be giving you the same plain text block, or you will not be able to decrypt with the same algorithm. So this is a figure. Plain text comes for the encryption process, gets divided into two halves, XORing takes place, and then the yellow portion will tell you that the ciphertext is then fed as the input for the Feastel structure. It then again gets divided into two halves, left and the right, and the same process takes place as it took place in the process of encryption. It then swaps the bits, and then whatever the output you get at the end will be the decrypted plain text. These are some of the design elements of the Feastel cipher, wherein we do require a specific block size, we do require the key size. Also, we do require the specific number of rounds for the process of encryption. The number of rounds for the process of encryption and the process of decryption for a particular Feastel cipher or for a particular block cipher will be same. Sub-key generation algorithms are required. As I told you, that random key generation algorithms will be requiring for generating the random keys or the sub-keys for every single round. And the round function. This particular Feastel cipher helps in fasting the process of fasting the softwares of encryption and the decryption, and it eases difficulty to analyze the encrypted text, or it eases the difficulty of analyzing the ciphertext to the plain text. Thank you. I just hope you might have got the concept of the Feastel cipher.